Okay, in this problem, we've got this graph, and it's a line graph, right? It's has a linear equation on it, a line, right? That's a linear equation, and it's talking about what? The change in water temperature of a glass of tap water placed in a freezer. So we're freezing water, and it tells you right away that if you put water in the freezer and you're trying to freeze it, the temperature is decreasing over time. And look at our graph, right? As time is increasing from 0 all the way to 40, our temperature starts at 25, and then by the time we're up to, let's say, 30, right? So at time is 30, that's our x value. I'm writing this as a coordinate. What's our y value? Well, we look to the left here, it's at 10 degrees. So if we look at two key points, 30 being one of them and maybe 20 being the other. So at 20 minutes, we were at what? 20 minutes, we're at, looks like 15 degrees. So from 20 to 30 minutes, right, from 20 to 30 minutes, we go from 15 to 10 degrees. So our temperature is falling here. What do they want to know? Use information in the graph to determine how many total minutes it takes the water to reach 0. Oh, so when will we reach 0? And they want us to explain. So I feel like in this problem, there are different ways to approach it. One way is to recognize that since we have a line here, all we're doing as time goes on is extending the line, right? And you can see right there that it's going to cross at this point. And you could say that, well, what's that point? Well, this is 45 right here. This is what? That's 50. So I think at 50 minutes, we're going to reach 0 degrees. But I think we should also explore another way of thinking about this. Since this is a line, right, we can represent the equation of a line with this formula. And we'll go over the details of this in other videos, but it's y equals mx plus b. And basically what we're saying is when you're representing a relationship that's linear, a line, first we've got to, well, not first, but often you got to think about what's the b value. And b is just called the y-intercept. What's that? Well, that's the starting point. At 0 minutes, right? Where are we up here on the graph? We're at 25. That's what this value is talking about. It's saying, what are we starting at? So in our case, the y-intercept equals 0. Well, 0 is at the point 0.25, but this value, I'm sorry, is just recording the height, 25. So if we want to write an equation that represents what's going on here with this relationship, we can use this formula, and we're actually almost done, right? Y equals mx plus 25. And once we have this formula, we can make a prediction. We can plug in x values and get y values. So next, I need to know, well, what is m? That's the slope. And I got to figure that out for this problem. If you remember, if you've ever seen this before, if not, we're going to go over it in detail in other videos, but m equals what's called delta y over delta x. And what does that mean? Well, delta y means difference in y, and delta x means difference in x. What does that mean? Well, delta y means subtract any two y values from our coordinates, and delta x means subtract two corresponding x values. So look at this, we already have points right here, right? Let's subtract these two y values. That's our delta y, right? This is our y1, and this is our y2. And don't get confused about which one's y1 and y2. I could have picked this one as y1 and this one as y2. It won't matter. But if you pick this as y1, pick this as x1, just so you can keep track of your order, and this is x2. So let's say we have y1 minus y2. Okay, so that's 15 minus 10 over divided by 20 minus 30. And if we simplify this, what we get is, well, 15 minus 10 is 5. 20 minus 30 is negative, what is that? Negative 10, sorry. And if we simplify this, we can divide both numerator and denominator by 5, and we get negative 1/2. So our slope is negative 1/2. And that means that we have an equation that can make a prediction. And it makes sense that it's negative, right? Because we're losing value as our x values increases. So we want to know, when does our temperature give us a y value of 0, right? Because our y value is our temperature. At some point, it's going to be at 0, at this height right here. We want to know when. So let's solve this equation. 0 is going to be equal to negative 1/2 x plus 25. Well, I want to know what x is. I want to know what my time will be. So I'm going to subtract 25 from both sides. And this gives me, I'm going to work down here a little bit. Well, positive 25 minus 25 is 0. We still have our negative 1/2 x. Plus 0, whatever, we're done with that. 0 minus 25 is negative 25. So now negative 1/2 x equals negative 25. I'm going to multiply both sides by negative 1 because I want to get rid of these negative signs. Cross that out. So negative 1 times negative 25. That is, right, two negatives multiplied together is a positive. That's positive 25. That's going to equal, well, negative 1 times negative 1/2 is positive 1/2. So now 1/2 of something is 25. And you might realize, well, that something has to be 50, right? So we were right in our prediction here. So 50 times 1/2 is 25. But if we didn't know that, when you're dealing with the situation right here with fractions, if you want to get rid of a fraction's 1/2 or anything, multiply by the reciprocal. It's a very useful tool. And if you remember, the reciprocal is just a fraction flipped upside down. So here our fraction is 1/2. Flip it to 2/1. So you have 1/2 times x times 2/1. I'm going to multiply these two, and that's just 1. So that's 1x or x. But again, when we're dealing with equations, you have to balance everything out. So if I multiply this side by 2/1, or just think of that as 2, I can multiply this side, 25. Multiply that by 2. And 2 times 25 is 50. So recapping, what we said here was that we figured out the equation of a line that represents this relationship. We said that we want to know when it's 0 degrees or when our y value is 0, and then we plugged in that value. So we said when this is 0, what does everything else equal? We subtracted 25 from both sides, multiplied by negative 1 to leave it positive, and then we have 1/2 of some amount of x or some amount of time will give us 25, and that's at when x is 50. So when x is 50, y is 0. That's what we're showing here. In other words, when x is 50, y is 0 degrees. So when x is 50 minutes, we have a temperature of 0. And I'm not sure what they're going for here on this test, but I mean, I would explain it either way, right? We know this linear relationship. It's constant, so we can just extend the line and see where it crosses the x-axis, or we could just solve using this equation right here. But anyway, I hope that helped.